Greetings, Earthlings. Well, it's time to take another look at the Keithley 171, see if we can work through the latest problem, and maybe that'll be the last one. Who knows? So, to review, we've apparently tracked the problem down to the analog amplifier board, which is this one here. Because if I pull that out, then I can put a voltage in where that was providing the voltage, and I'll get reasonable readings. So this is what the circuit looks like. There's a differential amplifier here with some FETs, and then 3 op amps, and then there's a feedback loop. That one and that one, the op amps, that's a 741 there. That one and that one are LM301s, which is what we had on that AC converter that was bad, which is very interesting. And actually looking at it, I can see that both of them were replaced at some time in the past. Probably about the same time as the other one, because they had 1976 date codes. Everything else in here is 73, 74-ish. So what I've done here to try to track it down, so basically what we're seeing is the output is random and totally regardless of what input there is, and so it's probably an active component. It could be here, it could be here, it could be here, it could be here. I'm hoping it's not here, or there's this chopper FETs, and I really hope it's not those. These I can get if I need to, but I don't have any. This I have, this I have, this I have. So I'm hoping it's an op amp. What I've done right now is I've taken this op amp out to break that feedback loop, okay? And then I've taken the output, which is pin 6, and I've grounded that. So coming back is 0, and then we can check the output of this op amp on the motherboard. It comes out to the connector that it plugs into. So there's a point on the motherboard where I can actually see what that output is. So that's what we're gonna do, just to show. Can you see that there? The socket. So I took the op amp out and I put a socket in its place, so that if it does need to be replaced now or in the future, well, actually the original one I'm not going to reuse just because it was its leads got all sort of mangled when I took it out. So I've got new ones. I got a bunch of them. So that's what's going in there. I will replace it with a new one. But then I have this jumper, and it comes over here, connected to ground. Okay, and again the input is shorted to ground, so I should be reading 0. If everything's working right, even with that op amp in place. But in this case, it will read 0 because I've set what the output of that op amp is to 0, and that's feeding the analog to digital converter. But let's take a look now. You can watch over here. And I'm going to check that output from that op amp, the first op amp in the chain, by plugging this in. plugging this in, powering on. Okay, and you can't see it, but it shows 002 on the front panel. I've set it to the 1 volt range, so there's no so it's a direct feedback path. These feedback resistors here. There's no resistors in the way in the feedback path when I'm on a 1 volt range. Okay, there's a place here on the board that I can test that output, and it's right there. No, that's not it. Oops. It's hard to get this on there. Well, it looks like it's 0. Which says everything's okay there. If that, oh. It helps to attach the negative probe. Let's try it again. See, I was all set to let that op amp off the hook and check the 741, but let's check this here if I can get in there without zapping anything. And this is kind of hard to do. Something there. All right, we're going to do this the other way. Tilt this up. I'm going to put this in here. Pin 4 is 1, 2, 3, 4. This is pin 4 right here. See, I was on this. That's just a feed through. I was on that on the top side of the board, or trying to get to it. It's kind of buried in there. Okay, what do you got? Oh, 0.492 volts. Well, that looks like a problem because looking back at this, the input is going to be 0 because I have that shorting bar on there. So that's basically direct path in through switches and resistors and stuff. But so there's should be 0 volts coming into here, which goes to this side of the differential amp there. All right, resetting here. There comes a time in certain videos when it's best to edit out a whole lot. And I know I'm going to be throwing away a whole lot, and just summarize it and get on with it. So what I've done to this point is I have 2 LM301As here, which I noticed had been replaced. And how could I tell that? Well, from the solder pads being a little shinier, and from the date codes being 1976, where everything else is like 73, 74. So I've taken those out and replaced them with sockets so that I can test with those out of circuit and also swap in different chips. Well, okay, so with new chips swapped in, it doesn't change the behavior. Fine. It's not those. Over here's a resistor. I've lifted the leg. So, what's going on here? We have this circuit, and there's like 3 op amps here, and those are the ones that are now socketed that I have tried replacing, just because I suspected them, and for other reasons. As I poked around and measured voltages in here, it just seemed like. It seemed to me like that one was suspect. But in order to get to that decision, I had to pull this one out to break the feedback loop. Anyway, it doesn't, it's not this one. Okay. What I'm seeing is voltage here at this node. Now, if I pull this card out and measure that on the back plane, it's 0. So it's coming from this card. Okay. This is the resistor I've listed. So you can see here there's plus and minus 15. Okay, and it would come down here. So that could affect this point. But what else can affect it? Well, there's diodes. Diodes can be bad. I checked the diodes. They're fine. There's a capacitor. You know, it's not bad because it would have shown up when I checked the diodes because I didn't take the diodes out. And that leaves these things. Because, well, actually, the voltage I'm seeing is here. Not there. Well, it's there, it's here, it's everywhere. I don't know. So there's these MOSFETs, which are switching MOSFETs. This is basically it's a chopper amplifier, which today would be, probably one. They would use one integrated circuit. Back in the day, they didn't have that, so they needed FET inputs. So they have discrete FETs here on the input, and then multiple stages of gain, and then there's feedback, and then this is the chopper switch here, which switches between the input signal and ground. Okay. Where's ground? This is actually the ground level here. Okay, so that's coming in there. So the only way this point, there's a capacitor there. It reads 0 on this side of the capacitor. There's voltage on this side of the capacitor. And that's what this grounded. Okay? And this is at ground. Okay, so the chopper is switching between ground and ground. I should never see anything but ground there, I wouldn't think. But I do see voltage there. 3 volts, yeah. So that says it almost has to be coming through these, one or both of these transistors. How can that happen? Well, I have a thought. They're switched. There's circuitry over here to switch them at a 227 hertz rate. And so there's a switching voltage that gets put on the gate. If that switching voltage is passed through, then, it could end up here. Well, it can't be passed through, right? Because it's a field effect transistor. That's infinite resistance between there. That's an insulator. That's like a capacitor. Well, let's have a look. That's these guys over here. And the interesting thing about these is they have this thing connecting them, which generally when you see that, that's like a thermal thing. You want to keep them at the same temperature. I don't think that's what's going on here. Because, first of all, they're just switches. I could see these other ones. These are the differential amplifier. Or those are ones that might want to have that, and they're not, and they're plastic. And oh, by the way, it looks like maybe one of those has been replaced, because those should be like a matched pair, basically. And if you look. I don't know if you can see this. One of them, they have the same part number, but one of them has these little paint stripes on it, and the other one doesn't. Okay? And looking at the soldering, I don't know. I can't really tell. But it's possible that I would guess that one's been replaced because the paint marks probably mean it meets the certain specs that you need it to meet. And you'd want both of them to be meeting those specs, and basically that should be a match pair, like I said. Here, you see there's like some glue or something between these. So there's a metal that wraps around, and here it wraps around, and then there's plastic or glue between them, which is probably not very thermally conductive. So I don't know why that's there. It also would be electrically insulating, although that's this lead here, this funky lead, and they're both connected together. In fact, we can show that. Anyway, they are connected together, so it doesn't need. You see that? Whoops. It doesn't need to be electrically isolated. Okay, but this is the gate. How do I know that? Well, because it comes over to these test points here, and looking at the schematic, the gate. Let's look at this one. This comes around. Where does it go? Oh man, it goes way over here, and there's test point 20, and the other one is test point 21. Okay, and those are these right here. So that's the gate. The center one is the case. That center connection here. So let's measure between the gate and the various connections. Okay. This one shouldn't have, well, neither one should have any connection between the gate and anything else. So I should get OL across the board, and I do. That's good. This one likewise. Now this one, these two I think are connected together. Yeah, and you can see that here. So that's intentional. But what about this? Okay. Overload. Going to the center one now. No, I'm going to the bottom one. Yeah. There's the problem. Okay. There's the problem. That transistor's bad. That is an HDIG 1030. It's listed in the manual as an RN 1030, but the markings on the transistor, well, if you look at other documentation online and find what they use, people have looked at the actual markings on the transistors and seen that they're HDIG 1030. I think I can see an HD on this one of them. Yeah. You're not going to see it. But right in there, I can see the HD part of it. So anyway, good luck trying to find those. I'm sure there are some out there, at military prices. But a suitable replacement is a 3N163. That's 3N, not 2N, okay? Because it's an FET. 3N163. Those can be found, or actually a 3N164 would work too, because both of those, 163 and 164, have better specs than this 1030. Those I can find. I've ordered some. I want to replace both of them together. These probably ought to be matched, They ought to switch at the same or approximately the same voltage, and that's certainly not guaranteed with discrete parts. So I may want to check them to see if I can find two that are fairly closely matched. So yeah, we're waiting on those parts, and that's about all we can do for this video.